Hi everyone, I'm here with your 233 lesson, How Can I Understand Products, Generic Rectangles, and Greatest Common Factor. When you solve a puzzle, is there always one answer? To a crossword puzzle with words, this is typically true. There's only one way that letters can be entered so that everything will work and match the clues. But in a number puzzle, there may be more than one answer that fits the clues. As you work today, think about and discuss with your team whether there is more than one way to solve a problem and how you know this to be true. 270. There are several ways to write the dimensions of a rectangle at right. How many ways can you write the dimensions of the generic rectangle at right? Draw a new rectangle for each way. So there are a couple things you could do here for 270. You can continue to draw your rectangles this way, or you can switch them and draw them this way. But you want it to be 120 and 18. So go ahead and pause the video and work on that. Okay, so some ways you could have done, you could have had 60 and 9, which would have been 2 over here. You could have had 40. Oh, that's supposed to be, yeah. And 6 and 3. You could have had 20 and 3 and 6. Okay, so there's some options there. B says the factor on the short side of each of the rectangles you drew in part A had to be a factor of both 120 and 18. When two products share the same factor, that is called a common factor. What do you think is meant by the greatest common factor, GCF, of 120 and 18? What is the GCF for 120 and 18? If you need to review the meaning of factors, see the math notes box in lesson 1, 2, 3. So go ahead and figure that out. So hopefully you said that the GCF is the largest common factor. And in this case, that would be 6. Moving on to 271. In problem 270, the greatest common factor and its generic rectangle could be used to write a multiplication sentence with parentheses. 120 plus 18 equals 6 times the quantity of 20 plus 3. For each generic rectangle below, draw as many rectangles with different dimensions as you can. Then use the greatest common factor for the numbers in each rectangle to write a multiplication sentence with parentheses. So go ahead and draw your rectangles. Okay, so I'm not going to draw your rectangles, but you should have come up with 4 ways for A, so 4 different rectangles, and you should have come up with the fact that 8 was your greatest common factor. So your sentence should have been 40 plus 32 equals 8 times the quantity of 5 plus 4. For B, there were 8 ways, and 54 was our GCF. So we should have 216 plus 54 equals 54 times the quantity of 4 plus 1. That should be your number sentence. 272. Ethan thinks that 5 times 13 can be found by adding 50 plus 15. Is Ethan correct? Draw a diagram to demonstrate Ethan's idea or show where he went wrong. So go ahead and work on that. Draw a diagram. So if I had my diagram, we would have 50 over here and 15. So he's saying adding 10 plus 15. Or I'm sorry, 50 plus 15 can be represented by 5 times 13. So when I do that, 5 is our common factor, and then we're breaking down 13, so it would be 10 plus 3. So now you would have to figure out if that's correct, which it is, because 5 times 10 is 50, 5 times 3 is 15. Now write a multiplication sentence with parentheses to represent Ethan's generic rectangle. Go ahead and work on that. Okay, so we have 50 plus 15 equals our GCF, which is 5, times the quantity of 10 plus 3, which would then equal 65 if you solved. Okay. That is it for today. If you want some extra practice, you could draw some generic rectangles underneath 273, but we do not have to do that. So if you have any questions, please let me know by emailing me or stopping to see me.